Hello everybody, welcome to my class of Algebra of Quadratic Inequalities. So today we'll see that how to solve quadratic inequations. So let's share the screen. Here you can see the topic algebra of quadratic inequalities. So here you have to find the range of values of x for which 5 by 2x squared plus x minus 15 is less than 0. So in order to do so, first of all, we factorize the denominator if it is not. So what we can do is like the denominator you can see this is 2x squared plus x minus 15, and then if you factorize this, so it is going to be 2x squared, and if you multiply 2 times of 15 it's going to be 30. So we have to work for 30 hours, so here you can write here 6 minus 5, which is 1, and times x, and 6 5 are 30, and then minus it is 15, and then you open it up, so it is x squared plus 6x minus 5x minus 15, and then from these two you can take 2 commons, 2x common, so it is uh, x plus 3, and from these two you can take minus 5 common, so it is x plus 3. So when you take now x plus 3 is common to the both terms, so you can take out this common, so it is x plus 3, and then it is 2x over here, and then minus 5 is left over here. In this way we have to factorize the denominator. So once you have factorized it, you can write now the main expression is 5 over 2x squared plus x minus 15. So as we have already factorized this denominator, so write that in the factor form. So it is x plus 3 and 2x minus 5, and this sort of thing you are given as less than 0. So now how we work with all these things, so you can see that it has 2 to 3 components. Like one component as you can suppose that as x plus 3, and another component you can suppose that as 1 by 2x minus 3, 2x minus 5, and then finally uh, you have all together, if you combine this 5, I haven't introduced 5, so you can write 5 by x plus 3 or 5 by 2x minus 5, both will work, but it can be done at last also. Like only the thing that we have to introduce is 5 over here while combining these two functions. So here it is x plus 3, and then it is 2x minus 5, and we have to find the final sign of this expression based on the signs of uh, expression 1 by x plus 3 and 1 by 2x minus 5. So in order to do that, what we have to do actually, we have to search these points on a real number line. All right. So first of all, if you work with x plus 3, then you put x plus 3, that means is 0. That means x is going to be, and then if you transpose to the right, it is going to be negative 3. So you have to search one negative point over here, negative 3, and then another point by another denominator. You are given that another denominator as 2x minus 5, then you put that equals to 0, and then you'll get x equals to 5 over 2, and that is in fact 2.5, so positive 2.5. So for example, if it is 1 and if it is 2, then 2.5 is something is somewhere here. This is 2.5. So we have to search the sign of these terms individually between different range of values of x. So here, first of all, our point is -3. So what we do, we'll search sign for 1 by x plus 3 and also for 1 by 2x minus 5 below minus 3. That is -3 to -infinity. Then 0 is in between. Then you can try for -3 to 0. And then after that, your another point is 2.5. Then you have to try finding the signs for 1 by x plus 3 and 1 by 2x minus 5 about 0 to 2.5, because we have 2.5 as reference point. And then for the point sign for the points above 2.5, that is from 2.5 to plus infinity. And same things have been done here. So if you check this here, that find the range of values of x for which 5 by 2x squared plus x minus 15 is less than 0, and we are looking for solutions for this inequation. So here, just earlier, we have factorized the denominator, and then we have taken the reference points. Those were -3, 5 by 2, and now 0 also will take as reference. So we search for the sign below -3, then between -3 to 0, then between 0 to 5 by 2, that is 2.5, and then above 5 by 2. So in order to do so, we develop a kind of table here, and then in the table, you take the range of values of x for which sign of 1 by x plus 3 is positive or negative, for which sign of 1 by 2x minus 5 is positive or negative. Once we found out the sign for these two terms, sign of 1 by x plus 3 and sign of 1 by 2x minus 5, and then we have two terms here. So if you multiply negative sign, for example, if it is negative, so negative times negative is positive. So let's see how to search this. So here, first range of values for x is -infinity to -3. And note that if it is like something like written like a and b, a comma b, for example, and both have the small bracket in this case, this means that x is less than b and bigger than a. All right, that means x is between a and b, but x doesn't include the value a and b. Similarly, if you are given that this is the big bracket a, b, and another big bracket, so that means it is a is less or equals to x is less or equals to b. That means x is between a and b, including both a and b themselves. All right, then can you guess if it is a small bracket a comma b, then closed by big bracket, or if it is a with big bracket start and then b and close this by a small bracket. Okay, so here this is called open interval, where the meaning is like this. This is called the closed interval, and the meaning of this closed interval is like this. And this is called the semi-closed or semi-open interval, you can say. That means x includes here b but not a. Here x includes a but not b, but x is between a and b. So here we have taken -infinity to -3 in the small bracket means we never know where the negative infinity is. So always we keep infinity side under the small bracket sign. And here why we are taking -3 in this case in under the small bracket sign is that if you look at this inequality, yes, if you put x equals to exactly -3, the whole thing is going to be undefined, because 5 minus 3 plus 3 is 0, and times this is 0. So 5 by, your term will be like 5 by 0, and it will be undefined. Therefore, we can take up to just less than negative 3 value in the analysis table. Okay. Now let's check with that. If you put x equal to negative 3, it's not going to be defined, but it means that x is less than negative 3 and is less than negative 3 and is bigger than negative infinity. That means you can try with some other number, like less than negative infinity is negative 4, maybe negative 5. So if you put negative 4, so negative number is bigger here, so minus 4 plus 3 is minus 1, so whole thing is going to be negative. And uh, in this term also, if you put any number less than minus 3, that is negative 4. So if you put minus 4, so minus 4, any number 2 is positive, so if you multiply this 2x by any negative number, this answer is going to be negative, and negative minus negative is again negative, so sign for this term is also negative. And this is the final term of the final equation. For example, you can see here, actually you need to find the sign for this combined function or the main function. So in order to do so, what we can do, actually we multiply these two signs. So you can see here that this is negative sign and this is also negative sign. So, and this term is formed by multiplying these two. So two signs will be multiplied. So minus times minus will be plus. So sign for this final or the main function will be plus. And the similar thing we experiment with the values between negative 3 to 0 including, and then from 0 to 5 by 2. Okay, where 5 by 2 is not included, because again if you check here, if you put here as 5 by 2, then you have 5 by 2 times 2 and minus 5, and these two are going to be cancelled. So it is 5 minus 5 is 5 minus 5 is will be 0. Therefore we take the value of x just less than or just below 5 by 2. So that situation you can see, therefore there is a small bracket. And here also again 5 by 2 to infinity. Okay, so we take 5 by 2 in the small bracket because of the reason that the final term will become, or this term will become undefined. And plus infinity, we don't know where is it, therefore we take real number just before the infinity. That we have done here, we'll do the similar work for all these terms, and then we found it is positive. Then in this range of value of x, this is negative, and for 0 and 5 by 2 it is again negative, and 5 by 2 to infinity it is positive, and minus infinity 2 minus 3 it is positive. Let's check now whether we keep positive or negative thing, negative sign altogether. Yes, it is given that this sort of inequalities should be less than 0. So as this is less than 0, then we take negative sign, because negative sign means less than 0. So these two range of values have been selected for the solution. If that would be given bigger than 0, then in those cases, instead of selecting the negative sign area, uh, you would select the positive sign area. So here it is less than 0, so we select the negative sign area. So this two negative sign area includes negative 3 0 and 0 5 by 2. That means x is from negative 3 to 0. So one solution is like this, and then another solution is 0 to 5 by 2. So we can write here x less or equal to x, but is less than 5 by 2. Why it is less than 5 by 2? Because if you put equal to 5 by 2, your inequality will not be defined. So in this way, we can find the solution for the quadratic inequalities. Finally, you can see that it is possible to combine. So it is minus 3 to 0 and then 0 to 5 by 2. If you combine these two, so it is minus 3 less than x less than 5 by 2. And this is the answer for this sort of inequality. If you like, you can have a proper look again, or you can pause at some point where you feel it is important to you, and then have a look carefully. Okay, even if you like to see the graph or verify or check whether or not your work is correct, you can go to a graphic software. In the graphic software, you can check whether or not your work is correct or accurate. So here in this graphic software, its name is Desmos, and I just entered this function. My graph is like this. And if you want to check that for less than 0, for example, less than 0 means negative, this sort of thing should be negative. So here in this graph, you can see that I have taken the reference point that we had seen earlier while going through this inequality, and then it was one point was -3, another was 5/2. So I took the line x equal to -3 and the another line x equals to 5/2. But we have to find that we have a lot of spaces for the graph of this sort of function, but we require the graph in the range where 5/2x squared plus x minus 15 is less than 0. So you can see that this is value 3, and you can see that less than -3, all the values are positive, means this graph is positive. And also this is 2.5, and the value bigger than 2.5 for this curve, you can see that it is taking only the upper side of this x-axis. That means y is positive. That means the given function is positive. You require the function to be less than 0. So you can check here. So you can see that the but we require this sort of function to be less than 0. Here also you can see that this is the line x equals to 2.5. If you go ahead than 2.5, that is x is bigger than 2.5, then part of the curve is above the x-axis. That means y is positive, and hence this function is positive, but we require the function to be negative. So if you check this value again, and if you go towards right, that means if you check through the value of x bigger than -3, then you can see the part of curve is going down. That means this sort of function is negative. And again, from this value 2.5, value of x 2.5, and if you check for less value of x than 2.5, then you can see the part of curve is again towards below this x-axis. That means y is negative in this case, and that we required here. So therefore, from the graph also it is clear that your solution is between -3 to 2.5 or 5/2. Okay, this is another problem of algebra of quadratic inequation. You can either call it inequality, or also you can say this is inequation. All right, and here you need to solve it. We apply the same strategy here also, but main thing is that how you solve it so that our work will become easy and reachable. So here in this case, I have taken this to the left, and then you can see here, take the LCM of denominator and solve it. Then you will have term like this, and this is greater or equals to 0 after solving. So you may try solving this sort of thing and try to reach up to this term. Now we'll repeat the same work. So here you can see that there is x plus 4 and x minus 5. So we first work for the point of reference. So here x plus 4 equals to 0. It gives you x equals to -4. So I marked -4 on this number line, real number line. And then another point I can see is that this is x minus 5. So using x minus 5 equals to 0, it will give you x equals to 5. So I have marked x equal to 5 somewhere here. Yes, on this number line. And next we'll work for this also. 7 minus 14x equals to 0. And then if you solve it, it's going to be 14x equals to 7, and then it is x equals to 7 by 14, and then 7 by 14 is 1 by 2. So we have marked a point 1 by 2 over here, and then we'll do the same procedure. So you can see here we have developed the table from negative infinity to negative 4. This is not included here. You have to check that if you include this in this inequality, then what happens here in this inequality? If you include negative 4, so 1 by minus 4 plus 4 is 1 by 0, and it will be undefined. And what we have got, actually, we worked for the sign for this term, and this term individually, like we had done earlier in the previous problem solving. So we have sign for this is plus, for this is minus, and for this is also minus. You can see that this is 7 minus 14 times minus 5, for example, minus 6. So minus times minus is plus, so this is always positive. And this is minus 4, less than minus 4 is minus 3. So minus 2, minus 3. All right. So in this case also, for example, it is minus 3. So minus 3 plus 4 is plus 1. So 1 by 1 is uh, this is here, sorry, minus 4, and less value than minus 4 is minus 5, minus 6. So if you put minus 6 or minus 5, for example, it is going to be minus 1. So 1 by minus 1 is negative, 1 by minus 2 is negative. So any value less than negative 4, if you put here, the sign for this entire thing is going to be negative. And similar work you can, or similar concept you can apply here also, and it is found that this is negative sign. And similarly, for the other range of values of x, you can work accordingly, and your sign detail will be like this. Now, analyze this table now. So this sign is positive, another is negative, and last one is negative. And here in this question, while in this term, while combining all these terms, you are multiplying all these terms. That means the sign, all the signs will also be multiplied. So it is positive, and this is negative times negative is positive, and finally positive times positive is positive. So this sign is positive. You can see that there are two positive is plus and one minus. So plus times minus is minus. Here again there are two positive sign is plus, and then plus times minus is minus. And similarly for this range of value of x, and for this last domain of x. But what you have to select here, you can see that this term should be greater or equals to 0. Then you have to select the positive signs only, not the negative sign. So greater or equal to 0 means this is for the greater or equals to 0. This is for the greater or equals to 0, but negative sign is for less than 0. And this is also negative sign. This is for less than 0. This is not greater or equals to 0. So range of values of x, that is the domain that we have to select, where the final term is positive, is from negative infinity to negative 4, and from half to 1 by 2 to 5. And those are only the solutions. So here in this case, you can see that from the table above, graph of 1, that means graph of this sort of function, inequality, is x is less than minus 4 and x is between 1 by 2 and 5. You can see that meaning of this is like half is less or equals to x is less than 5. So these two are the solutions for this inequality. And if you like to check, or if you can see the entire sum, if you like, you may pause it here and have a proper look. All right. And if you like to check this sort of thing in the graph also, you can see here in the Desmos graph software. Okay, guys, I hope you are now clear that how to solve quadratic inequalities, or any other kind of inequalities that includes combination of term, combination of different components in an expression or in a function. So this is all for now, and thank you for your patience.